techniques to solve rational equations that end up being quadratic equations. So, we've seen this before. This should not be new ideas or new concepts. We've seen equations that had fractions in them. So if I had 1 over x plus 1 over x minus 1 equals 7/12. We remember doing back in the day, Liddy. Yeah, we need to get a common denominator for everything, right? So what is everything that's in our denominators? And remember, I kind of did the little trick where I wrote everything that was in the denominator off to the side. So we have an x, we have an x minus 1. We also have a 12. So in the first rational expression, what am I missing out of the 3? A 12 and the x minus 1, right? So I'm going to have to multiply that 1 by 12 minus x minus 1. Which would be the same in both the top and the bottom. The second fraction, what are we missing? A 12 and an x. So times 12 times x times 12, I'm just going to write 12x. And then in the fraction on the right side of the equal sign, what am I missing? Good. An x and an x minus 1, x and an x minus 1. So if all of my denominators end up being the same, what can we do? Yeah, just ignore the denominator and focus on the numerators, right? Because they would end up canceling each other out. So now let's just focus on each of these terms. So this would become what? 12x minus 12. So let's just write that as 12x minus 12. Here we would get 12x, so plus the 12x, equals, all right, so now let's be careful here, 7x squared, good, so 7x squared, 7x times a negative 1 would be minus 7x. So now we have an x squared terms, which means we have a quadratic term, which means we're going to have to solve a quadratic equation, which we are now masters of. Because my x squared term is positive here, let's move everything over to that side. This 12x and this 12x would combine to make what? 24x minus 12 equals 7x squared minus 7x. All right, so I'm going to subtract the 24x over to that 7x on the other side. I'm going to add a 12 over. Do I have any constant terms over on the right side to add the 12 to? No, technically 0. So now I get 0 equals 7x squared minus negative 31, so minus 31x plus 12. Choose your method. Yeah, I wouldn't want to complete the square on that because then I would have 31 over 7 and a 12 over 7. That could get kind of weird. I don't even know what 31 squared is. We could maybe see if it's factorable, but then I'd be sitting here waiting and trying all these different things to see if it's factorable. So let's just go right to the quadratic formula. So go ahead and start plugging that into your quadratic formula. So x is equal to negative of my b plus or minus the square root of, say it again? 961. Thank you. Minus 4 times my a, which is 7, times my c, which is 12, all over 2 times my a, which is 14. So 961 minus 4 times 7 times 12. Ooh, that's nice. 625. What's the square root of 625? 25. So this would have been factorable if we would have sat here and thought about it. So 31 plus or minus 25 over 14. Okay, so what are my two solutions going to be? 31 minus 25 is 6. 6 over 14 goes to 3 over 7. Right? 31 plus 25 is 56 over 14 is 4. All right. Do we have any of our solutions becoming extraneous solutions in the domain, restricted values in the domain? No, because what would have been the restricted values in the domain? 0 and 1. Good. So those are your two solutions.
Wait, why would it be 0 and 1?
Because what would make this be a 0, 0? What would make that be a 0, 1? And there's no x there. Okay? Got that? All right, let's do another one. We'll do this together, even though it says try on your own. 4 over x minus 1 plus 9 equals negative 7 over x. What's everything in my denominator? We have an x minus 1 and just an x, right? Because technically that 9 has a 1 in its denominator, right? We don't really care about the 1. So for the first fraction, what are we missing? An x. So that 4 is going to need an x. What's the 9 going to need? Everything, right? So it's going to need an x and the x minus 1. What's the 7 going to need? X minus 1. All right, so let's just focus on the numerator. So it looks like we're going to get 4x plus, what's this going to turn into? Good. Perfect. Equals 7x minus 7. Oh, yep, I didn't even see that. Thanks. So it'll be negative 7x plus 7. Good catch. Is my x squared term positive? Yep, so let's move everything over there and combine like terms. So maybe we should combine like terms first. 4x and negative 9x would go to, yeah, so we get 9x squared minus 5x equals negative 7x plus 7. So move everything to the left side, add your 7x over, subtract a 7 over. So what's my quadratic going to look like? It's going to be what? 9x squared plus 2x minus 7 equals 0. What are we going to go with? Quadratic? Yeah, that's the foolproof way to go. Quadratic every time. Less thinking involved. You just plug it in. So x equals negative 2 plus or minus 2 squared, which is 4, minus 4 times 9 times negative 7 all over 2 times my a, which is 18. 2 what? 280. So we're going to have to simplify. I got 256.
Wait, no, I did something wrong in mine.
I got 256. Anybody else getting 256? Yeah. So negative 2 plus or minus the square root of 256, which the square root of 256, that is a perfect square, is 16. So negative 2 plus or minus 16 all over 18. Negative 2 minus 16 is negative 18 divided by 18 gets us negative 1. Negative 2 plus 16 is 14 over 18 would be 7 over 9. Any of those extraneous? Nope. Yeah, it's a negative 1. If it was a positive 1, then yes, then it'd be extraneous. Okay? So far, so good? Let me see if there's anything crazier that you're going to get. Let's try this one really quickly. What time is it? We got plenty of time.
8 minutes is plenty of time.
Yeah, just do one problem. All right, hardest problem you'll see. Ready? 1 minus 1 over 3x minus 2 minus 1 over 3x minus 2 squared is equal to 0.
Why do you do this, Jeannie? It's personal. So wait, you just square the 3x minus 2?
So what do we need? We need 2 3x minus 2's for all of my fractions, right?
Do you have to do it to the 0 or now? Is it 0?
No, but you wouldn't really do it. The 0 would stay 0. So this is a 1 over 1. So what do I need in the denominator? Good. So this needs a 3x minus 2 squared. What does this fraction need? Just 1 3x minus 2. What does this negative 1 need? Nothing, right? And the 0, just leave it 0, because anytime you do anything with 0, it's going to stay 0. All right. What is 3x minus 2 squared? 9x squared, no. Think about it. 3x minus 2, 3x minus 2. It'd be end up being 12x, right? Minus 12x plus 4. What's this going to go to? Don't forget this subtraction sign. Good. Negative 3x plus 2.
Why is it plus 2?
The negative times a negative would go to a positive. And then this would just be a minus 1. Well, technically it is, but since we got the denominators to be all the same, we can ignore them.
Really?
Yeah.
What about at the end?
Well, anything over 0, if I would multiply it by 0, it would just go to 0.
No, not the 0. I mean, like, by the end, not.
When you get to your solutions,
Oh, never mind.
Justin?
If we got a cubed,
You're at least, but it's okay.
x to the third.
It's fine.
Well, we don't know how to solve cubed equations right now. Yeah,
I want to warm my
there is. You take the cube root of it. The square root of it. All right, combine like terms. 9x squared. How many x's do I have? Minus 15x plus 5.
1. Oh, it was 1.
4 plus 2 is 6 minus 1 is 5.
Yeah. Oh, it's because it's a negative 1.
Yeah, don't forget that negative 1.
Oh.
Do we want to complete the square for fun or not?
No.
You guys can do the quadratic formula. I'm going to complete the square for fun.
Fun.
She's a math teacher and she says that she wants to do the square for fun.
X squared minus.
Teachers are never challenging themselves. So they have to do it for fun.
It's good. It's good stuff.
The only math homework that I ever liked in this class is that crossword puzzle they gave us. I liked
Or the
it.
thing at Christmas.
Oh, I liked that.
I like that.
Actually, I gave up halfway and then I started guessing the
Do that
names.
together.
Am I going to beat you guys or not?
Yeah, probably.
You definitely will.
I don't like this challenge.
Oh my gosh, 9 and 6. I'm going to my calculator for that. I'm not taking those to 54. Or I guess I could take them to 18. I could take them to 18. I can take them to 18. I can do that in my head. Negative 18, 10 plus 1875. Yep. Oh gosh, I'm going to have to rationalize that.
Here's in Italy, right?
Yeah, okay, when she said, I don't know if you have your friends on here, I was like,
Your teacher said
thanks.
Well, she was more like, I don't know who you hang out with
Yeah.
besides Kira.
Besides Kira. I FaceTimed Kira over there, though.
What'd you guys get?
130.
5, 6, 65 times 2. I don't think I can simplify that further.
I got 5 plus or minus the square root of 5 over 6.
Did you guys get this? Did you get the discriminant to be 130?
It's 225 minus 4.
Should be 45. What did I do wrong?
I got 45.
Yeah. I didn't do it right though.
Just write no solution.
I'm kind of defective.
You should have gotten 5, 6,
On the other side, you did
plus or
25
minus
over
root
6.
5 over 6.
Oh, that's what I got.
Yeah, no, I see what you did wrong. You did 25 over 6.
Oh, it's supposed to be 36.
Yeah.
Thanks. Ignore that.
Wow, that one mistake made that really ugly.
Yeah, it did. So then that would have been what? Times 4, so that would have been negative 20. So then I would have gotten it. I would have been there. Negative 5 over 36, or positive, so then I would have had root 5 over 6. I would have had it.
You didn't work on the end, so